Hi everyone, I am Vivek. I am currently pursuing BTech in Electrical Engineering Department at NIT Silchar, and today we are going to discuss the Newton's Law of Motion. So, before jumping to the Newton's Law, all the three laws that Newton gave us, let us first try to understand what is force and what are its type. Okay, so force is something that changes the state of rest or a state of uniform motion. Uniform motion. So this is what we mean by force. So let us take an example. If there is a football and I have kicked it and it start moving. Initially it was at rest position, and after kick it start moving with a certain velocity or acceleration. So we say that the kick was the force applied, and that force will be equal to, we will ma, we will understand it further how it is equal to ma. But now, for at this point of time, we will understand only that the kick was something we call as a force, because the football was initial test and it started to gain some acceleration. Similarly, if there is a train moving at certain acceleration or certain uniform motion, and if we applied a brake on it, so what will happen? It will start to decelerate, and finally it will stop. So this is the braking force. So we have understood both the scenario. Coming to the types, there are two type of forces that we know. Okay, the first type is field force, and second type is contact force. Okay, so what is field force? Field force usually means that it doesn't require any contact between the two objects. Let us take an example. There is a wedge, mass m is kept there. Even if this mass m is not in contact with the ground will apply gravitation force of mg on it. So this is field force. The ground and this mass m is not in direct contact. Even if there is no contact between them, the force is applied. So under this field force, gravitational force is what we know, and another type is electrostatic force. So these are the two examples of field force. Similarly, if we talk about the contact force usually needs the contact between two objects, between uh, in between they are operating. Let us take an example. This is ma, another mass mb is there, and force F is applied. So there exists a normal direction between these two surfaces, that is contact force. So this will come under the normal force. Similarly, let us take another example. So mm, there is a wall, okay, a base is there, a string is attached, and a mass m is there. So there must be certain tension on this string, because here mg cos theta is force is applied. We will discuss it later. So this is called as tension force. We will study in next slide. So I want to just say that in contact forces, there has to be certain contact between the two objects. Here in first example, there was contact between MA and MB. In the second example, there was string attached. So this come under the contact force. Normal reaction. We have already discussed what is normal reaction. So let us take another example. There is a table, okay, and mass Ma is kept. So Earth will apply Ma into G in a downward direction. But why doesn't it fall on the ground? Why the table is holding it on its original position? Because the table will also apply a normal reaction N on it, and that normal reaction will be equal to Ma into G. So if there are two equal and opposite forces, they cancel each other, and hence the mass M is kept intact, kept at rest on the table. So this is normal reaction. Similarly, we have talked about tension. Let us take that example again. There is a wedge, there is mass M, string, rotor, and this. So how do you calculate the tension? Can we calculate? It is very easy. So M mass is there, mg will be applied on downward direction. Here in this direction, mg cos theta will be applied, and this will be equal to tension T, because this force is in direction with the string. So here the tension force will be equal to mg cos theta. This is the pull experienced by the string attached here with the mass. So that's it, how you calculate the tension. Tension is actually the pull experienced by the string. That is what we mean by tension. Let us now discuss how do you make the free body diagram. So free body diagram are the best way to solve the NLM problem. They actually consider the mass at point object, and uh, after considering it as point object, we will mark each and every force applied on that mass, and after that we will do further calculation. So that is the use of making free body diagram. Now let us jump to the example. Okay, let us consider the first example, this one. This is Ma. So in downward direction, Ma into G will be applied. This is gravitational force. In upward direction, normal reaction force applied by B, because it is kept on B. So NB will be applied. And now if we consider the MB that is kept downward, MBG, MBG will be applied in downward direction. Okay, and normal reaction by A will be applied downward, because A is kept upward on it, and in upward direction NB will be there. So this is the free body diagram of the first example. Similarly, for second example, if we take M as point object, force F is applied in right direction. So in order to maintain tension, T will be applied in leftward direction. In downward direction, Mg will be applied, and in upward direction, normal reaction will be applied. Similarly, if you go for the third example, consider M as point object. So Mg will be in downward direction, tension T will be downward direction, normal reaction by the wedge will be in upward direction. So this was the free body diagram of the third example. It is that easy. You have to just consider the mass as point object, mention all the forces, whether it is gravitational force, normal reaction, tension, whatever you see, and just plot it. That is the free body diagram. It is that easy to draw. Let us consider the final example to understand the free body diagram deeply. Okay, so we have this example. Let us consider point object MA, this object. So for this, MA into G will be in downward direction. Normal reaction by Earth will be upward direction. Tension T will be in rightward direction. This is the mm, free body diagram of MA. FBD of MA is drawn here. Similarly, if we draw the free body diagram of MB, so MB into G in downward direction, normal reaction by wedge. This wedge will apply normal reaction. No? Normal reaction will be this direction, perpendicular to the surface contact, and tension in the direction of string will be applied here. So this is the free body diagram of MB. Similarly, if we talk about the capital M, the wedge, capital M, so capital MG in downward direction, normal reaction by earth, tension T by string, this part of a string, and another part of string is this attached to it. So here the tension, let us consider T1, T2. So this was the free body diagram of capital M, that is wedge. So solving this question was also not very hard, no? It is very easy for all the three masses MA, MB and capital M. So we have done this question also. Now coming to the main part of this lecture, that is first law. Okay, it says that if an object is at rest, it will stay at rest. So again taking the example of football, so it was at rest, but when you kicked it, it started the motion, and that is why we say that the kick is a force applied on the football. Similarly, if let us take an example of train. So if a train was there in a constant motion, and if we apply brake on it, it will start to deaccelerate and finally stop. That is also the braking force. So this is the basic definition, basic understanding of first law. Jumping to the second law, this is very important law. It says that the rate of change of momentum is directly proportional to the net external force. Mathematically, we can write that d by dt of momentum, that is mv, is equal to force. So if we consider mass at constant, m dv by dt is equal to force, and dv by dt is what? Acceleration. So mass into acceleration is equal to force. And now we can understand that why people say force is equals to ma. This is the derivation of force is equals to ma, and from this we can comment that unit will be kilogram meter per second square. This is the unit of force. That is why I was saying that I will explain from where does this force is equals to ma comes. This is the second law. And the third law, most important law. Let us say we have a gun, a bullet is fired. So when the bullet eject from the gun will also feel the recoil velocity or acceleration. This is called the recoil force experienced by the gun in opposite direction. So this is what the third law says. For every action, there is an equal and opposite reaction. So this is the third law. Hope you have understood so far. Now this is the final question, and the application of the Newton law of motion that we have studied. So first we understand what does this problem says. We have two block of mass, that is m1 and m2. Weights are given, okay, and they are in contact with each other. The surfaces are smooth, so we don't have actually to take the tension, the friction force or something like that. The surfaces are all smooth. The horizontal force is applied, that is 3 Newton on the m1, and we have to calculate the contact force. So again, I have told you that first you make free body diagram. Okay, that is the first thing we have to do. For m1, m1g will be applied as a gravitation force by the earth. Similarly, normal direction n will be applied in upward direction to maintain that gravitation force. That F is applied in rightward direction, and to maintain that F, a contact force F1 will be applied by M2. This was the free body diagram of M1. Now we consider the free body diagram of M2. Okay, M2 also feels the gravitation force M2G. Also, it will apply normal reaction to maintain that gravitation force, and in rightward direction the contact force F1 will be applied on it. So this is the free body diagram of M2. We are done with both of the things, both of the free body diagram. Now we have to find the contact force. Okay, so what we are trying to do. Okay, so let us consider that acceleration with which the two body will move will be a. Okay, so by the first diagram, that is free body diagram of m1, we can write f minus f1 is equals to m1 into a. We have assumed that the body will move with the acceleration of a. Okay, and from the second diagram we can say that from the this was the first equation. Okay, and by the second diagram it says that this force F1 will cause all the acceleration because it is the only horizontal force here. So F1 will be equal to M2 into A. This is the second equation. Now if we add both of this equation, it will get cancelled, and F is equals to M1 plus M2 multiplied by A. So now we got our acceleration with which both the body will move after the application of force, that is F by M1 plus M2. This is our force. Okay, let me write again. Acceleration will be equal to F divided by M1 plus M2. This is our acceleration. But we don't have to calculate acceleration. We have to calculate F1, that is contact force. This F1 we have to calculate. So how do you calculate F1? Put it put simply in second equation. So after putting F1 is equals to m2 into acceleration, we got as what? F divided by m1 plus m2. So we got F1, and F1 is what? Contact force. You can see, no? F1, this F1 is contact force, this F1 is contact force because it is in leftward direction for m1, and for m2 it is in rightward direction. And if we see both as one entity, this F1 get cancelled because they are in opposite direction. And we can also infer from this point that contact force is an internal force, and sum of all the internal force is what? Zero. So this is also one inference that you can remember. So I think we are done with this example. Conclusion. So we have learned what are forces, how do you define force. Force is simply something which in the state of an object, whether it is on rest position or it is in uniformly moving object. So if you change the state of an object, that is called a force. Then we understood what the type of forces. That is, there are two type, contact force and field force. We have studied these two things also. Then comes free body diagram. We have done several example free body diagram to understand. And then three law of motion we have discussed. And finally, the question that we did here. This is the application of Newton law of motion. So thank you for listening me out. I hope you like the video.